We are watching a video today.
Oh my gosh, guys.
It's going to be your favorite movie. It is called Relationship Between the Volume of Prisms and Pyramids.
Whoa.
Okay, I claim there's 3 pyramids.
Oh, would you hush?
Wait, where's the little hole at? 8.
Not my grandma.
It's at the top, like right there.
4, yeah.
Okay. So this set of hands is going to pour this into this, the pyramid into the prism. How many do you think are going to fit?
4 1/2.
4, 2.5, 3.
4.
Okay, here we go.
4 1/2.
3 is gonna fit perfectly.
2 1/2.
It's 2. They're already on 3 though.
Y'all are not very good at faking it.
Did you go faster?
Amazing.
Oh, you just. Whoa. It's like,
Okay, since we had to fake that one, I'll go further.
okay, guys.
Oh my God.
There's
Oh my gosh.
Here's number 3.
I'm gonna do this, bro. Oh my God. 2 1/2.
It's 3. It's
3
3.
3.
The suspense is building.
It's literally 3.5 right now. I mean, no, it's literally 3 because 3 is gonna fit perfectly.
16.
There's so much left. Oh my gosh.
It's not like
Turn around and watch the movie, Jacob.
You sound like he is there.
Bro, come on, man. Get 3.
3. It's 3, my G.
Oh no! Oh!
Shut the rest of it. Shut the rest of it. Do whatever song.
It's so close!
It's not even half 3.
Yes!
Let's go! Sit down!
I told you 3 perfectly.
Oh, yeah.
Stand
Stand up!
You are screaming.
I am happy.
Why are you screaming?
Okay, there's more. But wait, there's more.
4. Let's see.
4. For sure you said it was 4. I thought you were talking.
It's 4.
This one's 3.
This one's 2 1/2.
This one's 3.
2 1/2. 4. 72. 4.
How many triangular pyramids
3.
will
3.
will fit? Calm down.
2 1/2. 2 1/2. 4.
Stop! How many triangular pyramids will fit inside one triangular
2
prism?
1/2.
Okay, here we go.
700.
We gotta
It's
see.
clearly 3.
What I tell you? This is 2 1/2. Yes or no?
This is gonna be 3. It's gonna be 2. Oh, shit, it's gonna be 2.
Got a lounge music going.
Yeah,
Oh,
2
no,
1/2.
2.5.
No, 2 and
Y'all said 2.5 on the last one.
2.75.
Look where that was got. This one's 3.
2.75.
This one's 3 right
I swear my God, it's 3.
Dang, you're making me look like I got you.
I'm glad I videoed y'all. For a second.
Well, if he doesn't spill the whole thing, maybe it might.
It's spilling everything.
He's not spilling.
It's 3. What do you mean, bro?
You already said
No, I don't care. I can take my opinion whenever I want.
It's 3, guys. I'm telling you.
What do you want if it's 3? You're kicking. I give it 72 or something. Wow, it's literally 3.
Shut up.
Oh, you see it's rigged.
Y'all are being videoed.
75.
This is still rigged.
No, bro, it's literally 3. I'm about to
Wait.
pop that thing out of the table.
Oh, yeah.
Yeah.
Oh my God.
You're wrong.
I'm wrong. I said wrong.
Okay, so what was my point?
We're smart.
It's all the
Don't do
same.
the book by its cover.
Math is the same.
Yeah, music was
There's
awesome.
nothing different.
Okay,
Math is
what was the point?
I don't know, but I
Don't
just
do the book by its cover.
Allison, you questioned the greatness of my movie, and you, my ma'am, little miss, were way into it. Yes, it's 3. They are 3. They are all 3. Okay, so we're going to start prisms and pyramids today. 3 pyramids will fit inside one prism. They have exactly, if they have the same base and the same height, 3 pyramids will fit inside one prism. So just like circles on this one, our magic number is 3 as well.
Yeah.
But it has nothing to do with circles. Okay? So we're going to kind of go through these notes a little bit today and talk about it. And I told you you'd like my movie. Y'all were way into it, screaming at the screen.
Not even right.
So y'all better tell 6th and 7th period too that they're going to get to watch a movie and
Yeah, but don't tell them the numbers.
and tell them. No, don't tell them the answers. Don't tell them the answers.
Tell them it's 5.
Yeah.
Don't tell them anything.
No, it's 72.
Don't tell them anything. Let them make their own deductions from it. But
Can we watch
you
the
can
last
tell them
one?
that you're going to watch. It's a cone. The last one is a cone.
Do it.
If you want to watch the last one, this document is in your Google Classroom.
Can I
Under-
subscribe?
The,
I'm sorry.
I'm recording. Okay. This document that's in front of you, that's also up on the screen, is in your Google Classroom. And that link to that YouTube video right there is the video we just watched. The last one is a cone and a cylinder, like a Coke can cylinder. And it also, 3 cones fit inside one cylinder.
You spoiled it.
And the reason I'm telling you is because the magic number is 3. I bet I've said that 5 or 6 times, the number 3s, in this little conversation we're having. The reason I don't show you the cone is because we don't do cones in 7th grade. So, but it is 3 also. Okay, we don't find the volume of cones, but this is volume. And you need to know that 3 pyramids fit inside of one prism. Why do you think I've said that so much?
So I can remember it.
Yeah, because it's important. Are you going to see it on the test?
Yeah.
Maybe.
Yes.
Definitely.
A question like that has been on STAR or a benchmark every single year. Okay, it says something along the lines of, how do you compare the size of a prism to a pyramid? Well, a prism is 3 times bigger than a pyramid because 3 pyramids will fit inside of one prism. Or if it says, how do you compare a pyramid to a prism? Well, a pyramid is 1/3 the size of a prism because 3 will fit in there. Are you with me? Everybody with me? Okay, so I'm going to start reading right here with the word if. If the base areas and heights are congruent, which means the same, then the volume of a pyramid is 1/3 the volume of the prism. If you have different types of prisms or pyramids, the relationship between them may be different. We're going to start with prisms and we're going to do volume. There are also many types of prisms which are also named after their base shape, such as a triangular prism, square prism, rectangular prism, pentagonal prism, etc. This is important. A prism has 2 bases, no more, no less, only 2. The rest are considered sides. Okay? How many of you have a highlighter? Just one of you has a highlighter in the whole class? That's it. If you have a highlighter, get it out. Okay. So, a prism has 2 bases, no more, no less. 2 bases, no more. Jacob, please turn around and face the front of the room.
Someone threw this at me, but I don't know what it is.
Please.
Squishy.
Turn around and face the front of the room. Please turn around and face the front of the room. No more, no less. The rest are sides. So if this is your square prism, then you can have the top and the bottom be the base, or the front and the back, or this. Jacob, please turn around and face the front of the room. It wasn't her. I can assure you she didn't do it. To find the volume of a prism, the formula is volume equals area of the base times the height. Area of the base. So this formula right here that says V equals and this B and this H, you do not say BH. You say area of the base. Okay? So when I say what is the formula for the volume of a prism, you do not say volume equals BH or V equals BH. You say V equals area of the base times the height, or big B. I'll even allow you to call it big B. Okay? The 8th grade teachers don't like it when I let you call it big B, but I don't care. Okay? I'm just kidding. My friend was an 8th grade teacher and she used to get mad at me. You are used to doing length times width times height, right? The reason we don't do that anymore, they've changed the formula. What they basically did is made the area of the base the length and the width. Okay, so it'd be like right here. You with me? And then the base back here, right? Right? You with me? So it's big B times the height. They've combined these two. The reason they did it is because this formula is very universal. For example, used to, if you were doing a triangular prism, this would be the formula. Now this is the formula. Which one looks easier to you? The new one. So it's more universal. So you just find the area of the base of the figure and then multiply it times the height of the figure. Is everybody with me? All right. So if you look at pyramids, the one down from here, there are many types of pyramids and they are named after the shape of their base, such as triangular pyramids, rectangular pyramids, square pyramids, pentagonal pyramids, etc. A pyramid has, write this down. No. A pyramid has what?
One base.
One base. Only one base. The rest are considered sides. So please highlight this rectangle here as the one base of the pyramid. You got it done? Now, to find the volume of a pyramid, the formula is volume equals 1/3 area of the base times the height. So here's that big B again. Where do you think the 1/3 comes in?
3 is that magic number.
That's right. 3 is the magic number. A pyramid is 1/3 the size of a prism. A pyramid is 1/3 the size of a prism. So you basically find the volume as if it were a prism and then multiply by 1/3. How do you multiply something by 1/3?
Make it to a decimal.
Anyone know how you multiply something by 1/3?
You make 1/3 into a decimal.
No.
That's right.
How do you multiply something by 1/3? The trick, the easy way?
Divide it by
What?
3.
Yep, divided by 3. That's exactly right. Turn the page. The contents of 3 pyramids with rectangular bases exactly fill one prism of the same base and height. That's exactly what I just said, right? But I wrote it on here again. Why do you think so? Why did I write it on there again? Yeah, because it's important. Both figures have congruent bases in the same height, so when you put the pyramid inside the prism, their bases overlap exactly. Since the shapes are the same height, the top of the pyramid touches the bottom of the prism. The pyramid clearly fits inside the prism, so the volume of the pyramid must be smaller. Given a prism and a pyramid with congruent bases in the same height, which has a bigger volume?
Prism.
Square.
Good. Notice I wrote this on here again, this time in big bold letters. When 2 figures have the same height and the same base, the volume of the prism is greater. The volume of the prism is 3 times greater than the pyramid. The volume of the pyramid is 1/3 the size of the prism. Hence, 3 pyramids will fit in 1 prism. You can circle that with your highlighter. That is an important part that you need to refer back to. You will use that quite a bit. All right. Turn the page. Find the volume of a pyramid and a prism. Given the figure on the previous page in which a square pyramid is placed inside of a square prism, we now ask, how many of these pyramids would fit inside the prism?
3.
3. All right, let's look at example 2. Find the volume of the pyramid with a rectangular base with sides that measure 5 centimeters and 13 centimeters. The height of the pyramid is 15 centimeters. First thing I want you to do, look right here where it says now find the volume using. You see that? That should be a V. That's a typo. It should be a V. Okay. So first we're going to identify the base. I know it looks like a square, but I put the numbers on there, so it's actually a rectangle. So color in the base. What is the shape?
Pyramid.
A rectangle. The base is a rectangle,
Oh.
right? Everybody got it colored in?
Yeah, it looks like
So now all we gotta do is, we got the formula written already, 1/3 area of the base times the height. And the way to find the area of the base is what? It is base times height. So we're looking for the base of the rectangle. What is it? 13. What is the height of the rectangle?
15.
No. We are just doing the green base. And 13 times 5?
65.
So the area of the base is 65. Now we got to do the height of the whole pyramid. What is it?
15.
15. Everybody stop right there. Everybody stop right there. You're going to have to multiply by 1/3. You can either multiply the 65 times 15 and then divide by 3, or you can divide by 3 first. Now 65 is not divisible by 3, but 15 is. So we can do that first. What is 15 divided by 3? 5. So now we're going to have volume equals 65 times 5. And what is that? Please, I'm recording.
325.
325. So that is how you find the volume of the pyramid. Let's skip over this and go right here to this. We're actually going to go to this triangular prism here. I need a volunteer. Okay, Angel, you're close. Come stand up over here. Yeah, right over there. Where everybody can see you. Everybody look at Angel. What's Angel's base?
His
butt,
feet.
feet.
His feet.
Legs.
His feet. His base is his feet, right? Lay down on the floor. What is Angel's
His
base?
back.
No.
His
His
butt.
His what?
His butt.
His feet. His feet are still his base. He's just laying down. Stand up. What's his base?
His feet.
Lay down. What's his base? His feet. Good. You can sit down. Thank you. His feet. His feet are his base. No matter what position he's in, his feet are his base. Even laying down, even in bed at night, he's on his side. His feet are his base. How many bases does a prism have?
One.
2.
2. Does it have 3?
No.
No.
No. 2. That's it. Doesn't matter what position it's in, it only has 2 bases. Prisms are named by the shape of their base. Just watch, please. Do not write. The name of this is a triangular prism. What shape is the base?
Triangle. I mean,
Square
rectangle.
rectangle.
I'm going to say it again. Prisms are named by the shape of their base.
Triangle.
What shape is the base?
Triangle.
It's a triangle. This is Angel laying down. This is his feet. This is his head. Do you see what I did there? It is like he was standing up and somebody laid it down on its side. How many rectangles are there?
1, 2,
Just a minute. Don't.
3.
How many rectangles are there?
3.
3. That cannot be the base. Are you with me?
No.
Please turn your paper back to the front and put your name on it and turn it in. We'll pick up there Monday.